Hi everybody. In this video we're going to jump into section 8.3 looking at some more examples. We're going to write equations from solutions. In particular, we're going to find a polynomial equation with integer coefficients for which the given numbers are solutions. Let's jump into example A. We want to find a polynomial equation with integer coefficients with 1 and 1/3 as solutions. Well, a prototypical kind of answer to this could be this. We just take x minus 1 and we take x minus 1/3 and we let that equal 0. But the problem is that this doesn't have integer coefficients. When we multiply this out, we will get some fractional coefficients. So the way that we get around this is we multiply by what's necessary to clear out fractions. So we can multiply both sides of the equation by 3. And let's think about what that leaves us with. Well, I want to leave this x minus 1 factor as it is, because that's already in integers, right? There's no fractions involved. But on this one, I'm going to multiply, so basically I'm taking the 3 through only this factor. Think about it that way. And I get this. And then 0 times 3 is, of course, 0. All right, awesome. Now we've given a polynomial with integer coefficients for which the numbers are solutions, but let's just verify by multiplying it out. This gives us 3x squared. We get a minus 3x here. We get a minus x here, so that's minus 4x plus 1. Now we have it. We have a polynomial equation with integer coefficients for which 1 and 1/3 are solutions. If you really like, you can, if you'd really like to, you can check that 1 and 1/3 are solutions to this. But I'll leave that for you to check if you're curious. Next, let's look at example B, where we have 2 root 3, 2 times the square root of 3, and negative 2 times the square root of 3 as roots. And it's really no coincidence that they come in these pairs like this. These are called conjugate pairs. But without going too much into that, again, we'll just kind of follow the same tactic. We'll take x minus 2 root 3 and take x plus 2 root 3 and set that equal to 0. All right, well, let's multiply this out and let's see what we get. Well, we get x squared. That's x times x. And then we've got the outer and inner parts canceling because these are conjugates. And then we need to take minus 2 root 3 times 2 root 3. That's going to give us minus 4 times 3, which is 12. That equals 0. And voila, we're actually good now because this is a polynomial equation and it has integer coefficients. The leading coefficient's a 1. For emphasis, I'll put it there. And the other coefficient's minus 12. So, of course, those are integers. Next, got example C, where we've got 3 roots now. Well, we just kind of follow the same process still. We take x plus 4. That will have minus 4 as a root. We take x, well, I'll write x minus 0 for emphasis. I'm going to change that in a second. And then we have x minus 1, and then that's equal to 0. And maybe I'll just write it like this now, just commuting things, writing things how they're typically written. I'll write the x minus 0. X minus 0 is just x, so I'll write that here. I'll bring the x plus 4 down and the x minus 1 down. I'm just reordering things, and that's perfectly legitimate because we're just multiplying. And next, we can see that when we multiply this out, we will have integer coefficients. Why don't we just go ahead and do that, though? We'll get x squared plus 4x times x minus 1, and then we get x cubed minus x squared from here, and then plus 4x squared from there. That's a plus 3x squared minus 4x equals 0. And there we have it. Pan this down a little bit. Oh, sorry, I accidentally refocused it too. So this, again, this is, what were we asking for? This is a polynomial equation with integer coefficients. So we're done. And lastly, this is probably the trickiest of the few. We want to get a polynomial equation with integer coefficients with root 2 as a root and 0 as a root. Well, let's think about that. Well, one thing I noted up here with letter B is that whenever you've got these radicals, they've got to come in these conjugate pairs. So let's sort of put that on the back burner though, and just see what happens when we try to apply the same approach. Well, we have x minus root 2 and we have x minus 0. We multiply this thing out, what do we get? Well, again, maybe I'll write it the more standard way. X minus 0 is x minus root 2. Okay, now we multiply this out, we get x squared minus root 2x equals 0. Now, what's really the problem here? Why is this not good enough? Well, it's right here. Right here, maybe I'll highlight that in blue. We have the square root of 2, and we want integer coefficients. So there's something incomplete about there only being root 2 as a root. So that is exactly what ties in letter B. Letter B here says that, or what I said earlier with letter B is that whenever you've got 2 root 3 as a root, you've also got minus 2 root 3 as a root. They come in conjugate pairs, and that's maybe I'll just refer you back to the quadratic formula. That's why we've got these conjugate pairs in place in those examples. So coming back down here now, we kind of have to rethink this a little bit. We can't only have x minus root 2 as a factor, but we also have to have x plus root 2 because minus root 2 is also a root. So this one's tricky. So minus root 2 is also a root. That comes from the quadratic formula. So if you want those details filled in, please ask me though in the future. But for now, let's go ahead and just erase what we've written so far, and let's put that important fact into consideration and see how it pans out. Let's also use the fact that negative root 2 is also a root. Well, that leaves us with x minus root 2 times x plus root 2 times x is equal to 0. I'll omit the x minus 0 bit. And now if we multiply this out, we get x times x is x squared. Remember the conjugates, the outer and inner parts, when you're multiplying conjugates, the outer and inner parts cancel, so you're just left with a minus root 2 times root 2, that's minus 2. And then you've got this times x is equal to 0, so that's x cubed minus 2x is 0. And there we have it. Now we've got ourselves a perfectly nice polynomial equation with integer coefficients. So that's good now. So that's the end of this video. I just wanted to cover a few examples like this. I might make another video about this topic, but anyway, we'll see you all in the future. I hope you have a terrific day, and stay safe out there.